Hey guys, welcome to the lesson about section 1.2, properties of real numbers. I kind of want to run through some of these things. I've given you the sheet and I want to talk through a little bit of this if it hopefully will help you do better in your homework as well as do well in the quiz that you'll take in a couple days. The commutative property, a lot of teachers teach a shortcut to say CO means change order. Okay, the only two things that you can basically change the order and still get the same answer is addition and then also multiplication. Because if 2 plus 3 is the same as 3 plus 2. Again, CO change order. If you do multiplication, 3 times 2 is equal to 2 times 3. Okay, you get the same answer even if you change the order. Other operations like subtraction, if you do 5 minus 3, or if you do 3 minus 5, you're going to get 2 and you're going to get negative 2. So that would not be something that works with a commutative property. Addition and multiplication, again, CO change order. The associative property has to do with you don't change the order, okay? You don't change the order, you just change what is in parentheses or how the numbers associate together. And again, the things that you can change, it kind of changes order of operations. It says do this first. We've got A plus B plus C and then still A plus B plus C. Again, we're not changing the order, so it's not the commutative property. You're simply changing kind of the order in which you do it by doing the things that are in parentheses first. And so you're changing A and B, add those first, and then add C. Again, if you do B plus C and then add A to it, the order kind of is the order of the problem is the same, but again, what's grouped together is going to be different items. Okay, who they associate with kind of changes the order of operation in which you happen to do the problem, but it doesn't change the order that you see them as they progress. ABC again, the order of the problem is the same. It just changes who's associating together in parentheses. First it was A and B, and now it's B and C. So again, the order doesn't change sequentially that you see them. It just changes who's in parentheses together, associating together. Identity. If you think about your identity, okay, we all have our ID cards, and so when you look at your ID card, whether you change your hair color or you wear a different shirt, you still have the same identity. And numbers begin, as themselves, and whether you add 0 or if you multiply by 1, they retain their same identity as well. And so we're looking to say, how can a number stay the same or keep the same identity? Well, you can keep the same identity by adding 0, that's the additive identity, or you can multiply by 1. 1 is the multiplicative identity. Okay, so those would be two ways that a number or a variable can retain its same identity by adding 0, additive identity, or multiplying by 1. Inverse, okay? Inverse means kind of the opposite, okay? There are many inverses we can talk about. We'll talk about inverse functions this year, but the inverses that you can speak about would be the inverse of addition, okay? The inverse of addition is subtraction. The inverse of multiplication is division. The inverse of squaring is square rooting. That's lots of different things. Well, let's talk about how we use this, okay? Say that you've got an equation. You've got x plus 5 is equal to, say, 8. And to solve this problem, we are going to do the additive inverse, meaning we want to get x by itself. So it's adding 5, so we're going to subtract 5 because a number plus its opposite will give us 0. We're going to x plus 0, or just x. So if you subtract it from one side, you've got to subtract it from the other side, so your answer would be x is 3. Again, a number plus its opposite will always yield 0. And so we use this when we solve equations, like this shown. But again, say that we've got the number 7. Well, its additive inverse would be minus 7. Okay? If you've got the number negative 20, its additive inverse would be positive 20 because negative 20 plus 20 gives us 0. So again, adding a number plus its opposite yields 0. Now the multiplicative inverse, okay, the product of a number times its reciprocal, again it can't be 0, but a number times its reciprocal will give us 1. And this is shown right here. If you look at this, you say you've got 3x is equal to, say, 18, okay? Now, normally we just say divisible sides by 3 and you're done. We could also say, well, let's multiply it by its inverse. The multiplicative inverse would be its reciprocal. So multiplying 3 times 1/3, okay? 3 over 3 is just 1, so that goes away. And times this side by 1/3 as well, so x is equal to 6. Again, the reason why we multiply by its reciprocal is because we want x alone. And so multiplying a number times its reciprocal, we'll get rid of it. We'll make it to be 1 or 1x in this case. So again, take any number times its reciprocal and you can get 1. Now, let's talk about this a minute, okay? On your homework, they're going to ask you to say, well, if you've got the number 2/3, what is the additive inverse, okay? Well, that would be negative 2/3 because this plus this gives us 0, okay? If they say, what is the additive inverse of, say, negative 1/8? Well, that would be positive 1/8, okay? Because the sum of these two gives us 0, okay? Now, on the other hand, if you're going to talk about multiplicative inverse, that means that, say, you've got, 2/3, okay? The multiplicative inverse of this would be 3/2 because the product of these two gives us 6 over 6, which is equal to 1, okay? So the multiplicative inverse of 2/3 is 3/2 because their product gives you 1. Multiplicative inverse of, say, 2 is going to be 1/2 because their product, half of 2, is just 1 as well. Say that you've got negative 1/3, okay? Well, we want our answer to be 1 again, right? So what do we have to multiply this through by? The reciprocal, which would be negative 3 or negative 3 over 1. Notice negative times negative gives us positive, so that would be the answer. Incidentally, if you wanted to take the additive inverse of negative 1/3, you would do 1/3 because their sum is going to be 0. So those would be a couple things that I think that might help you. Let's go back to the sheet, this distributive property, okay? The distributive property of multiplication over maybe addition or subtraction means basically distribute or multiply this value up front by each of the terms within the parentheses. And there is your answer. Distributive property tends to be pretty straightforward. You've seen this quite a few times. Now, closure. Closure is something that I don't know that you guys have seen a whole lot. Closure means that you're basically, the number sets are one big happy family, okay? And a number set is just simply a group of numbers, okay? And so you have many different number sets. You've got the natural numbers, you've got the whole numbers, you've got the integers, you've got real, you've got imaginary. There's all sorts of number sets we can speak about. Or you could just make up a number set and put it in brackets and show what that is. So let's talk about this closure, okay? So I'll get a fresh sheet of paper. Well, let's pretend that we're talking about a group of numbers, okay? So say that I've got the numbers 1, 2, 3, and 4, and that's my number set, okay? And my numbers 1, 2, 3, and 4, I'm going to say, is this number set closed for, I'll put a 0 here, okay, closed for the set of addition, okay? That means you can take a couple of these numbers here, and they can be repeated, and you add them together, okay? Closed for adding. And that's a question. If you add any of these together, will you get, as your result, a number that is shown here? Will you always get a number that is on that list as your answer, okay? And so you can take 2 of them together, you could take 3 of them together, but just take a couple of them and see if your result will be found within this set. That means it's closed, okay? You could live within this world, do as much adding as you'd like, and you'd always get an answer that falls within this. And if you look at it, sometimes it works. 1 plus 2 gives us 3. Yeah, that's in that set. You could do 0 plus 1, and look, you get 1, which is an answer there. You could do 2 plus 3, you get 5. And so the problem is that it sometimes works, but sometimes when you add a couple of these things together, you get an answer that you don't see within your world of the set that's shown here. It kind of falls outside of it. So therefore, this is not closed in the set of addition. Okay, so let's look at another group, okay? So say that you've got, let's talk about the the natural numbers, okay? The natural numbers are how you naturally count. So do 1, 2, 3, 4, or the counting numbers, 5, dot, 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 dot. Is this closed for addition, okay? If you take any of these together, will you always get a number that is in the natural set of numbers? Well, take two together. 2 plus 3 gives us 5. That's a natural number. How about 1 plus 1? You get 2. How about 1 plus 3? You get 4. How about 4 plus 5 plus 1? Okay, your result will be within the natural numbers. So the natural numbers is a closed set for an adding. Okay, so you could ask the question, is this set closed for subtraction? Take any two numbers here and see if you get your result is going to be within the set of the natural numbers. Well, it works for some of them, but what if you choose to subtract 4 minus 5? You get negative 1. That is not a natural number. So you can ask all manner of questions talking about if a set is closed for different operations, and as long as you take a couple numbers and you can do that operation, and every time you do numbers or do that operation, you always get a result within that set, then you would call it closed. If ever you try to do that operation and you get a number that falls outside of it, like when we did 4 minus 5, you get negative 1, this set, the natural numbers, would not be closed for subtraction. Okay, so those are a couple examples that may help you. I think that is most of the stuff that I think you need to know for this group. I will stop this. I look forward to talking to you another time.